actually does come out equal. Negative 21 plus 31 is the same as saying 31 minus 21, and that gives us 10, and it does equal the other side, which is 10, and we could put a little check mark. All right, so that's the basic understanding of one-step equations. We're just going to look at the other operations as well. I would, however, like you to circle number 2. Number 2, when you are done with notes, you need to have this one highlighted. You need to raise your hand and show me that you are able to solve this one on your own, and then I'll let you start your homework. But first, let's look at some more examples. So number 3 has some fractions in it, but we're still going to follow our same steps. We're going to draw the line, circle the variable, and do the opposite. So right here, it looks like they subtracted 3.5 from the variable. So the opposite of subtracting is adding. So I'm going to add 3.5 to both sides, plus 3.5. We draw our little line there. Negative 3.5 plus 3.5 cancels out, and the only thing we're left with is n. N equals, well, now we have some fraction work to do. I've already done that fraction work to the side, but remember, we're going to change this mixed number into an improper. So big by the bottom, add the top. So I just wrote that to the side over here. This is our side work area if we're not using it to check. Negative 4/5 plus 7 over 2. Now remember, with fractions, we have to make those common denominators. We can use the denominator of 10 since we can get there from the 5 by multiplying by 2. We can get there from the 2 by multiplying by 5. And then we end up with negative 8/10 plus 35/10. Now that they have common denominators, I can go ahead and look at the tops. Negative 8 plus 35 is the same thing as saying 35 minus 8, which gets us 27. So 27/10 is equivalent to 2 7/10. So I know n is equal to 2 7/10. And I will put a box around my answer so that I'm sure to see it. Again, remember, this is a video, so you are welcome to pause and go back anytime you need to see something again. On to the decimal one. Again, hopefully you see these same steps. Draw the line, circle the variable, do the opposite. Now here it's a little tricky because it says plus negative 4.32. Plus a negative. Well, that means I'm going to either minus a negative, or I could take the sign that's directly in front of that number. I just want that number to go away. And the opposite of a negative 4.32 is a positive 4.32. So I can add 4.32 to both sides of this equation to make this one go away. That's the additive inverse, if you recall. So I'm going to take those away. They cancel out because they're opposites. The only thing I'm left with on this side is W. And now we have to look at what W equals. Now you see my work here. This is a negative, that one's a positive. Since they're different signs, I'm going to actually subtract and keep the sign of the bigger number. So I have more negatives, so I know my answer will end up negative. And then I just do that subtraction, lining up the decimals because these are decimals. And we get 9.10 minus 4.32, we get 4.78. And so I know the answer is going to be negative 4.78. And we put a box around that. All right, on to another example. Now, I'm not going to go through too many with these. Just for sake of time in this video, I want the video to be less than 15 minutes if possible. So let's go over here and look at some multiplying and dividing. Let's go to an easy one. Number 7, there it is. Same steps. Draw the line, circle the variable, but this time it's a little bit harder to see what the inverse operation would be. Anytime we have a letter with a number directly in front of it, that means multiplication. So what this says right now is 7 times y. The opposite of multiplying is dividing. So instead of times, I'm going to divide both sides by 7. That would allow this to cancel out. So 7 divided by 7 is a 1. So I could write 1y. But remember, standard form, we don't need the 1 in front. So I just leave that y equals, and this is the division that I have to do. So I've done that division to the side. 91 divided by 7 gives us 13. Since I have no pair, I know that this will be negative. So my answer is going to be negative 13. Now remember, we could always go back and check by plugging that in for y and checking that 7 times 13 is 91, or 7 times negative 13 is negative 91. Now remember these steps. Our original problem was the given, and we used division to get to this answer, so it would be the division property of equality. All right, up next, number 8 looks a little funny. That one looks like a fraction, but it actually is just division. Draw the line, circle the variable so you can see what they're doing. And we can go ahead and write that this was our given. That's our given equation, so it's called the given. Remember that, yes, this does look like a fraction, but fractions are fine. That's just division. So the opposite of dividing by 3 would be multiplying by 3. And whatever I do to one side, I have to match on the other. And so that's how we would get our answer here. If I were to extend this fraction line, I could then see that I've got a 3 over 3, which would cancel out again to a 1. So I have 1x equals, and now I just do that multiplication. Negative 4 times 3 is negative 12. Since I used multiplication to get there, this one would have used the multiplication property of equality. Okay, so there's a division, there's a multiplication. Let's go ahead and I will scroll down to a funny looking one with a fraction on the bottom. Here we are, number 11. I'm going to draw the line, circle the variable just like before. Now we do see the variables on the right hand side. For now we could leave it there, that's fine. We'll switch it at the end to make sure the variables on the